Today's episode is Nature-Based Solutions, How Daphne Water Solutions is Fighting Water Chemical Pollution. Luisa Orsini is a professor of evolutionary systems biology and environmental omics at the University of Birmingham and is founder and CEO of Daphne Water Solutions. Driven by a passion for improving environmental health, Luisa pioneers cutting-edge research at the intersection of life sciences and AI, exploring the impacts of environmental change on freshwater ecosystems. Her groundbreaking work has led to the development of a transformative water reclamation technology, which she successfully patented and commercialized to support net zero carbon emissions goals and provide clean water solutions globally. Through her leadership and scientific expertise, Luisa is translating research into real-world impact, helping to create a more sustainable future for all. This technology is a real beacon of hope in challenging times. And with that, we extend a very warm welcome to you, Luisa, as our presenter today.
Thank you so very much. It's a pleasure being here. And I will start with sharing my presentation and inviting you to ask any question. Please feel free if anything is unclear. And thanks very much for giving me the chance to share today how we are trying our best to fight chemical pollution. Before I start, I want to introduce myself briefly. As Jennifer mentioned, I wear several hats. I am a professor at the University of Birmingham, and I'm also a guest professor at the University in Germany. I'm a deputy director for an international and multidisciplinary center for environmental research and justice. I lead two facilities at the university, and one of these is on Daphne, which will become the center of this presentation later on. And last but not least, I have then founded in 2021, and I'm the CEO of Daphne Water Solutions. And this is a startup that is delivering sustainable tertiary wastewater treatment. Is this an easy balance to take or to keep? Not really. It's challenging. But the advantage is that I am always aware of real-world problems. As a scientist, I face these problems head-on, and this leads to solutions that are grounded in scientific evidence. So being at the interface of science and business gives me that edge, if you want, to address real-world problems. Let me start with a context. So you might or you might not know, if you heard of it, about planetary boundaries. So these are boundaries. These are the boundaries that within which we are safely operating on Earth. So within the green zone, we are safe. When we exceed this green zone because of overexploitation, because of pollution and other reasons, we are outside the safe operating space on Earth. And between 2009 and 2023, we have exceeded more and more boundaries. And now in 2023, we have exceeded 6 of 9 planetary boundaries. And why is that? Reasons are diverse, but definitely the main culprit are climate change. So we not only observe an increase in average temperature, but also an increase in average extreme events. So we have now witnessed across the globe how much floods and droughts have really ravaged many lands. A second culprit is definitely eutrophication. It's also known as nutrient pollution. So it affects rivers, lakes, marine environments. And just here an example of a lake, natural lake that becomes eutrophic. When you go and transition to this phase, essentially you cannot fish anymore, you cannot swim in it anymore, and it becomes a lost resource. And probably the most culprit of all and the most worrying are chemicals. And you probably know, but it's a staggering number. There is more than 250,000 chemicals in our environment. And many of these have unknown effects, because the test on individual chemicals and their health effect is only completed on less than 2% of these chemicals. And many of them are mixtures that happen to end up in the environment from different sources. So they are not planned. Therefore, we don't know what kind of impact they might have. And what this causes is water degradation, soil degradation, biodiversity loss, and poor human health. And many of these chemicals, you use them every day. So there is pharmaceuticals that humans use for health. Same chemicals might be used for farming. There is personal care products. Every time you shower, you do washing, you are introducing these chemicals in the environment. And the third main source is through agricultural land use. And we were discussing with Jennifer and some before, some of the most infamous are probably PFAS. These have become much more in the spotlight recently. And for people that might not be aware about them, it's good if you are. They are present in the majority of our consumer products. And they were introduced in the 60s, and for their properties, they are resistant to water, oil, grease, heat, and so on, and therefore are very suitable for a number of applications. But the same reasons that makes them very suitable makes also them very resistant to disruption. And so what happens is they tend to accumulate in the environment, and they are very, very challenging to remove. And they are a growing concern for health because they are known to cause many health effects, including cancer. So many of these chemicals, and I want to focus on this today, end up in water. We tend to think that planet Earth is covered in water, and so we shouldn't worry about this resource. However, fresh water on Earth only amounts to 3% of the total, and of this, just above 1% is readily usable by humans. So what this means is that even though our planet is covered in water, the amount of fresh water we can really use is very limited. And to compound this complicated situation, we are polluting our water through the waste. And you might think, wait a second, I mean, we treat our wastewater, so we shouldn't worry, right? I wish it was the case. Wastewater treatment processes remove effectively pathogens, and so those are the ones that make us sick. However, they are not really good at removing what we call persistent or forever chemicals. So these are pharmaceuticals, pesticides, and other industrial chemicals I introduced just briefly before. And these chemicals escape the treatment of traditional wastewater processes. And so they end up in our rivers. River water is used as irrigation source, is used for water recharges. Essentially what happens is that this chemical accumulate and make their way back to our table through our food and water. And this makes us sick. And in fact, pollution is responsible for more than 9 million people death every year. It's not only from water, but water has a very important contribution to this. So in addition to health impact, these chemicals have also an effect on our economy. And with the increasing regulation from EU, US, and UK regulators, industries are more and more forced to reduce them. However, they often are in breach of compliance, not necessarily because they don't want to meet this regulation, but because there are not enough technologies to remove them, and it's not very clear what regulatory limits are as yet. And most of the existing solutions tend to be very costly, and funny enough, they can produce byproducts that are more toxic and more nasty than the actual chemicals that we introduce in water. So is it all doom and gloom? No. And I'm very convinced that science and innovation and responsible innovation at that can make a difference. And so today I want to share with you what we have done and we continue doing in this sector. So meet Daphnia. Daphnia is a water fleas, are small crustaceans that you can find in majority of lakes and ponds across the globe. And there is many of them in Europe, in the UK. And they are typically used by regulators to define safe use of chemicals in water. What we have done as scientists here at Birmingham is to develop this system to be both a detector of water pollution and then as a company to become a cleaner of water, as a microscopic vacuum cleaner. And the reason why I call it that is because it's a filter. It's a biological filter that takes all the water in, and by doing so, it also takes up the chemicals. It is Daphnia has a transparent body, so it is possible to see organs through, to see the effect of pollutants, and it's small enough for us to work in the field as well as in the lab. So the small organism has many advantages, as I mentioned before, and it's what is called a sentinel species, similar to canaries in coal mines at the beginning of the centuries. What makes them similar to the canary is that they are more sensitive than humans and other animals to toxic exposures. They share the same environment as humans, and they have, when they are exposed to toxic substances, they have measurable outcome. So, for example, the canaries would stop singing when they were exposed to fumes, and this was an indication for the miner that something was happening and they had to leave the premises. Daphnia works in the same way in water by telling us beforehand what are chemicals that are toxic potentially to humans and other animals before these chemicals become extremely toxic to us. And another advantage or very quirky aspects of these organisms is that they have a very long dormancy. And when I say long, it's really long. We are talking about decades or centuries. You can think of these dormant stages as seed plants. So they can sleep for a very long time. They can be reawakened later on, and then they germinate. Why is this relevant, and how we collect this dormant Daphnia is by sampling a sediment in lakes. So you can see we use very fancy equipment to go in the middle of a lake, and what we use is a corer. This is a plastic tube that by sheer pressure can be pushed through the sediment in the lake, has this video shows. And what it happens really is that it enters the sediment, it creates a sort of a big carrot, if you want, and then this carrot of sediment comes back to shore. It is as big as a human being, so it can cover many years. And for example, in this case, we go back to the 1800 by sampling this sediment. And what happens there, which is relevant, is that this sediment could be sliced. So it's put in this contraption and is extruded from the bottom up. And so what you do is to slice layers of sediment as with a cookie cutter. And this allows you to create centimeter by centimeter a new record of this sediment. The important thing is the sediment can be dated, and so whatever you extract from it, you know exactly the age of. And that's very relevant for our Daphne work. So once we have done this, collected sediment and extracted our Daphnia, we expose them to light and temperature stimuli, And what happens is that what was a few thousand cells in this dormant stage picks up where it left off. And so it becomes slowly, within 48 hours, a fully functional adult. And so you start from few cells and you end up with swimming Daphne. The advantage is that then you have a resource of strains that date back to the 1800 if you need. And each one of these new living thing can be maintained as a clone in the lab, similar to what you do with bacteria, which means you have an infinite resource to rely on. Now, this is cool per se, but it has many advantages, and it has also sparked all the work we have done for the bioremediation technology. What this allows us is to look at strains with different histories of pollution, of exposure to pollution, and to see which one is, for example, more tolerant or resistant to chemical. We have done this with forever chemicals like PFAS and microplastics. We have done this with pharmaceuticals, as well as PAHs, which you might know as the chemicals that come out of incomplete combustion. And they are everywhere. So what this allowed us to do, to discover, is something we really didn't expect. As an evolutionary biologist, I was expecting that animals that were exposed to certain chemicals, or to chemicals in general, were much more tolerant to chemicals because they evolved the tolerance. However, what we discovered was that animals that were re-exposed to the same chemicals showed a high tolerance. But the strains that were most tolerant to a diverse number of chemicals were the pristine ones, so the ones that never seen chemical pollution before. This was unexpected, however, it makes sense because these organisms that never seen chemicals before are more acting as generalists, and so they are less depauperated of their ability to respond to chemicals. And this was the foundation for this science-driven innovation. So in addition to using Daphne as our early warning system of pollution based on its history of exposure, we then use this very resistant strains for bioremediation of wastewater. And this is how Daphne Water Solutions was born. And as scientists driving this innovation, our ambition is really to make this technology available to everyone, including and especially developing countries, for which water is such a scarce resource, and especially children, but all the population is dying from pollution. And how this technology works is actually very simple principle, but it's all very much driven and driven by science. So what we do, this is a tank in a wastewater treatment plant. Is typically known as a secondary clarifier. So this is the last treatment before water is discharged in the rivers. Now, based on what I said before, this water is supposed to be clean, but in fact, it still has a number of chemicals, quite a high number. The majority of them occur in very low concentrations, and this makes it even more challenging to remove them. So what we do, we take our historical Daphne and we put them in these containment devices. You can think of them like coffee filters. So the coffee filter contains the population that thrives in these waters and filters naturally whatever water is there. And by doing this, it filters all the nutrients that are still in this water, as well all the chemicals that happen to be there. And once it has filtered, the water quality has improved. And so what we return to the river is a way cleaner and safer water. Now you will appreciate, because this is a living organism, it doesn't need electricity, it doesn't need energy to live. The only thing it needs is solar light. So it is, therefore, the technology becomes affordable. It doesn't require a lot of infrastructure, and it is sustainable. Because Daphnia reproduce clonally once it's in natural conditions, we don't even to do much in order to keep the population running. And if there is any shock event, we have a side stream bioreactor, a sort of Daphnia farm that is used first to seed the population the first time in the tank, and then later on to top up eventually if there is any problem. Now you appreciate that this is a living organism, so eventually it dies. So the dead Daphnia stop swimming and they are collected at the bottom of these containment devices, and they have to be removed from the tanks and the filters because they eventually can release the chemicals back in the water when they rot, for example. So what we do, we take them away, we funnel them away for further treatment. The advantage here is that instead of now you have treated megaliters of water with these small creatures that don't require energy or any other attention, and you have now concentrated all these difficult small concentrations of chemicals in a biomass that is very small. And so it is much more manageable to be treated further to destroy these chemicals. At the moment, we are treating this bio-waste with incineration because only very high temperatures will destroy these chemicals. However, at the same time, we are also working to create a sustainable treatment for this waste. And this is based on light and nanoparticles. And the idea is that if we can break down all the very resistant chemicals, the waste that is the Daphnia itself could be recycled. Because now the Daphnia has phosphorus, nitrogen, and other nutrients captured, and the advantage is bioavailable. So you can take the waste and use it as a fertilizer. And this will be a major advantage because in most of our agricultural land, we are depleted, especially of phosphorus. So in the long range, and I hope in a couple of years we will get there, we will create a completely circular system that is completely sustainable and allows us to recover not only water as a resource, but other resources as well. And this is to show you how our little Daphnia do in a wastewater treatment plant. This is a prototype we have run. And you can see this small swimming Daphnia are really happy in this water. Sadly enough, this water is very similar to surface water in which they would live in. There is a concentration of different chemicals, but there is also a number of nutrients. And so they happily swim and filter in this water. And now, just to give you an idea, what are we able to remove? Because that's a big question, I suppose. So majority of existing wastewater treatment, and these are tertiary wastewater treatment, if they are efficient, they are also very polluting, or they require a lot of energy. Majority can remove certain type of chemicals, but they are not very good with others. What we show here, and I'm showing here, is that Daphnia, as a sustainable technology, can remove a wide range of chemicals, including microplastics, PFAS, hormones, and a number of pharmaceuticals. And these are the only ones, the ones we have tested so far. In addition, because Daphnia eats all the nutrients in this water, it also provides a further polishing step. So it makes the water cleaner before it enters the river. And so the end result is a clean, reusable water with almost zero carbon footprint. And the good news is that we have tested it across 12 months in different climatic conditions, because one of the potential limitation of a living organism that it can do better or worse depending on environmental conditions. And you can see here We went through summer, winter in the UK. We went from heat waves to almost zero temperatures. We had rain. We had solar irradiation going from summer to winter. In all these conditions, the Daphne thrived. And this was a very good outcome for our test. It means that we can apply this technology in diverse conditions and also in different geographic locations. So to summarize, this is our journey to date. I started with my aha moment in late 2017, where I was just a scientist using Daphne for evolutionary biology and genetics. And then I started thinking, wait a second, if I can use it to test chemicals, it means it also absorbs them. So does it absorb or transform them was a question that we posed. But then starting from this idea, I partnered with engineers. We have now completed a prototype test with real wastewater. We are preparing for the upscaling in a wastewater treatment plant. One of these is already installed in South Africa. The other is upcoming in the next couple of months in the UK. And we have secured a number of patent applications. Only the US patent is now pending. And the idea is that this will bring us in the next few months, we will be commercially viable to offer this solution and to take on the market. And the demonstrators we are planning are in collaboration with water industry, but also with the National Trust, which has much more the push to do things sustainably, which is very much our ethos. And some of the work we have done has been supported by the Horizon Europe Innovation Grant called Upstream. Other is being supported by research money, and as well as support from the National Trust and these companies that have invested in our ideas. And because it's a quirky, a different kind of approach, it has attracted a lot of attention in the media, including The Guardian, the BBC, and so on. And this has brought apparently our technology to the attention of Jennifer, who introduced me before, and I'm really glad that it did. We want to reach out to people. We want to make it known to others that this is possible. And to give you confidence, the leadership team at Daphne Water Solutions is a mixture of competences. There is myself as a biologist. We have 2 engineers. We have 2 environmental lawyers. And we are also supported by a number of advisors and consultants. We are also part of the Innovate UK Business Growth, which supports fast-growing startups. And what is my message to you to conclude is, if you are an investor, if you are an industrialist and you see potential in this technology, we are very much looking forward to working with you. If you're a person from the general public and you want to understand more or you want to be more involved, these are links to our website, and we welcome your input. We are trying also to develop now an educational program around DWS and Daphne, so that it reaches out also to kids as young as 10 years old with a game, as well as to all the kids that are in high school and they have to learn about sustainability. So we're very much about engaging with the public, and I look forward to your questions. Thank you very much.
Wow, I'm feeling great. That was amazing. Thank you so much, Luisa. Woo.
Yeah, I'm quite excited after that. There's some hope and and realistically, in such a short time frame. I mean, from 2017 to some wanting to be rolling it out commercially almost within 10 years. That's amazing.
Yeah, it's I'm hoping that this year is a year we just go commercial. It should be. So it is 8 years from a idea in my mind to a commercial solution.
And I couldn't help but think that I would much rather not pay Thames Water to clean my water. I would rather give you that funding to make this project happen. What if we all did that? Wouldn't that be amazing?
Yes, it would. But we have to partner with the water industry. You know, they have to buy into this. And I have to say there is interest and there is a drive to do more sustainable solutions. But somehow the water industry is also constrained by regulations and when they come on board and what they have to meet as standards. So it's a complex reality.
Can I just ask, do you see this on both sides, filtering the sewage water and the water for drinking? On both sides, would that be a double impact?
So if you are thinking, well, the answer is the following. With this solution, we cannot deliver drinking water because there is another step you need to do. However, in South Africa, where there is so much water shortage and they want to recycle water, they're actually thinking of combining this solution with a disinfection stage and then reuse the water for drinking. That is something I can see. I wouldn't feel confident giving people drink the water without disinfection because there are other standards to be respected.
Yeah, but in terms of chemical removal, I remember when I spoke to Thames Water, was it last year, that they said that basically they dilute quite a lot of these chemicals rather than remove. So it'd be quite exciting to actually have the Daphne remove these chemicals.
Yes. So they do dilute. I don't know to what extent this is true, is whatever comes through the system. And it could be variable over time. And a small proportion of these chemicals is removed by the bacteria. So the other process is more upstream, but the majority goes through. So they don't dilute really.
And I'm going to ask a quick question before opening up the floor to everyone else. Remember, you can put up your virtual hand or pop a message in the chat. Is there anything that Daphne can't digest? Is there like a maximum contamination limit, or are there any particular chemicals that Daphne can't manage and would actually sort of result in their death?
Yeah. So if it's exposed to very high concentrations of chemicals, it might result in death or other problems. But what we find in effluent water is never too high to kill them. What they mostly tend to do is accumulate. And I cannot think of more challenging chemicals than PFAS. So I'm pretty confident they can remove quite a lot of them. In some cases, like for simple chemicals, they can break them down in less toxic compounds. Majority of the time, like for microplastics or PFAS and so on, they simply accumulate. And so they work as a natural filter. They concentrate this thing so that the trace contaminants that are in water and are very difficult to remove are actually absorbed and concentrated in this small amount of waste. Then you can then treat forward.
Okay. Has anyone else got a question?
I can jump in. I've got a question if that's
okay.
Yeah.
I can't see who that
Sorry,
is.
that's all. Oh, it's Lizzie from South Against Sewage. Sorry.
Hi, Lizzie. That's all right.
First of all, thank you so much. It's so interesting and it's really exciting to hear about these, nature-based solutions, and it feels so innovative. It's like you said, it's great to know those options are out there. My question was around two things. One's quite specific, which is like pet medication and how successful it is in treating that.
So in a pet medication is not much different from pharmaceuticals that we take. And as I've shown in one of these slides, we have measured up to 35 compounds, and many of them are pharmaceuticals. And things like diclofenac, which is one of the most abundant antibiotic we use, also both for human and animal health, it removes up to 99%. And other things removes with different efficiencies. It will never be 100% efficient. you might think of having multiple serial dilutions and cleaning steps. It's still going to be much cheaper than doing any other application, even if you do serial application of Daphne technology to clean an already half cleaned sewage. I don't know if I made myself clear.
Yeah, you have. No, thank you. That's really interesting. And then I guess the other thing as well was just around something you already touched on with kind of like, I guess, like water companies, or how you kind of envision working with them and those stakeholders going forward. Because I think we already touched on this, but the kind of lack of innovation there is in that sector and the restraints they have
Yeah,
is,
so they have constraints, and that's true. However, we have to work with them because
Mm,
they are the ones dealing with the wastewater.
yeah,
I have to say our approach has been always to have our early adopters, so the one that is a bit more adventurous or thinks a bit ahead.
yeah,
This has opened up the market for us. So if these companies are then testimonials, it would be more easy or easier for others in the sector to adopt.
yeah. Because I
But
completely agree, and I feel like these solutions are the ones that are needed, right? Like the kind of more
yeah,
nature-based issues.
and consider that water companies are one of our customer, but they are not the only one. And the fact that, for example, we were approached by the National Trust is a very clear indication that we have applications in other sectors as well.
Yeah.
And especially National Trust is much more driven by sustainable solutions and net zero carbon footprint because they are more attached to the government and to sustainability. And our technology is flexible enough to adapt to these different conditions.
Mm,
And therefore, we can help in different sectors. It could be also beverage or food industry. They produce wastewater.
yeah.
Instead of discharging it directly in the river, we can improve the quality before it's discharged. So potentially the applications are diverse because the technology is flexible. Where I would expect more challenges and more optimization is if we are targeting, for example, pharmaceutical waste or hospital waste. That would be much more concentrated. So it might pose different challenges.
Well, thank you. Yeah, that's really interesting.
Next, Mark, you've got your hand up. Would you like to ask a question?
Hi, yes, if I can. It's maybe more than one, but it's just thinking about the process. What kind of volumes are involved here, and is there a dwell time? Is it through flowing water, or is it going to be in still water?
No, as I mentioned, we retrofit. So we install in the tanks. The tank is an open flow system, so there is a gentle flow because the water comes in, settles, and then it's discharged. In this phase of that has a retention hydraulic time of up to 4 hours, the Daphne do the job.
Brilliant. Thank you.
Yeah, and the volumes, to answer your question, it could be as small as a tank of 10 liters or as large as 20 megaliters of water because it's modular.
Okay, so if you've got a big sort of setup, say with a water treatment works, sorry, a sewage treatment works, and thinking about sort of flow through that, what kind of abundance of Daphne is needed?
150 to 200 Daphnia per liter.
Thank you.
But it's not a problem. The point is you can seed the tank or the cages with as little as 10 Daphne, and then they will eventually grow and they reach capacity and they continue doing the work. And the advantage of having this organism is self-regulating. So it will reproduce clonally, and then when there is too many animals, it will reproduce a bit less. And when there is too few, it will reproduce more. So it's self-regulating. It will oscillate around an optimum for the population. And this is what it would do in a lake. So it's not much different to what will happen in a lake. Where the challenge comes into play is if it's really, really cold, but water will never be below 6-7 degrees. In our most extreme conditions in the UK, the water temperature was around 4-5 degrees. Here, the number of Daphnia declined a little bit, but then we have the Daphnia farm on site. We just harvest a bit more and we top up the population, and then they will continue their work.
Jennifer, do you want to ask your question?
I was just wondering what the life cycle timing from birth to death.
From birth to death. So between the birth and the time they start reproducing is 6 to 7 days. And then after this, every 3 days, they produce up to 30 copies of themselves. Wow. In a natural environment, they have predators, competitors, and whatnot, so they don't have a very long lifespan. In controlled conditions, like, labs and stuff, they can live up to 3 months. But you never get rid of them in a way, because they keep reproducing, right? So there is continuous recycling of the population.
That sounds like it's not a bad thing. more Daphne, the better.
Yeah. They are self-regulating, so it's fine. Honestly, we never had to quit the prototype and start over.
Wow. Right. Anyone else?
Well, I was wondering, how can we sign up to get one in the even load, or 13 or 19, depending? How soon do you see this rolling out on a mass scale?
We can do it now. You don't need to wait for a mass scale. We can come and do it for you.
How much is it going to cost?
Well, not much as compared to what is on the market. We are like several order of magnitude below. So depending on the size and the scale, it can be very modest cost. And we don't do it again to have money. We don't want to become rich. Is really to improve water quality. And as I said, we are also working with national trusts and similar wetland trusts. So if you think there is room for an application, please do reach out to me, and we get a conversation like offline, what we can do and what you want to treat.
Yeah, so it's not just sewage treatment. It could be used for maybe natural flood management, sort of natural.
Yep.
That's amazing.
Yeah, and also, I don't know if you have lakes and needs to be remediated. That's their natural habitat. It would be a natural application. For example, we are now discussing another application that removes excess algae before the drinking water is passed through the system. So that is to show there are different ways we can apply the technology, and it's always a natural and low cost application, but it could serve different purposes.
And what about on a massive scale, like reservoirs?
Yeah, so the reservoir is possible. What you have to consider in the reservoir is that we have to contain them somehow. So either all these containment devices have to be built so that the animals are not in competition with others and not eaten by fish, because they are a delicacy for fish. So that's the cost, really. What we're doing with Severn Trent is, for example, they have a system of filtering the water reservoir, but what they have is a huge amount of algae. So there is a buffer tank where the Daphnia does the job before the water goes back in the reservoir. That's one way to look at it. So you can detour the water, filter it, and clean the water that goes back in the reservoir, or you can install in the reservoir. The advantage is that we do have a very flexible system, so we can retrofit. But if the water industry doesn't want to risk, for example, their infrastructure in any way, we can also do these as end of pipe solution, so as a separate unit. That makes it flexible enough for different needs and different applications.
That's really incredible. I'm just taking some notes. So just to be perfectly clear, there aren't actual regulations that are slowing this down. It's a matter of basically driving them to be put in.
Actually, the Environment Agency is very flexible because Daphnia is a natural thing, is a natural organism, it's no GMO. And the point is that if we treat water and it ends up in river because one of our cages breaks, they can't survive. So eventually they will die out. So there is no real impact on the environment. And the Environment Agency has authorized our treatment for the National Trust and for the wastewater treatment plants. I'm sure that there will be potentially a modification of permit that will be necessary in any case. But if we are a separate unit, probably not even that. What is stopping, it's really de-risking for industry, because this is a new thing. And as any new technology, it has to gain traction. What scares the water industry a bit is that they cannot control this as they would control a filter. But the only thing they need is a biologist, which is not very costly. So as long as you know how to deal with Daphnia, it's not a big deal. And what we do as a company is provide them with the right strains to do the job. That's coming from our science, so we know what we're doing. But otherwise, the maintenance of this infrastructure is not really demanding.
And I'm going to talk about another pollutant now. We've discussed recently about road runoff. Obviously, there are sort of filtration, ways of dealing with road runoff pollution. Could this be used for road runoff? With the runoff going into, say, a tank filled with Daphnia, and then it could be cleaned.
It's very funny you mentioned that. It's a discussion we are having with the Wetland Trust in the UK. They want to start tests for road runoff cleanup using Daphnia. They already have sedimentation ponds with plants they tend to use for these things. And there is discussion if Daphnia could replace that or it could combine with this solution. The replacement would be an advantage because there is much less impact on the land used, because we need a very small space as compared to wetlands which take much more space. I'm hoping that I can give you an answer in a few months. We are waiting for them to get organized and for us to test it.
And again, would the heavy metals play havoc, or can they still manage the sort of the really nasty stuff that comes from road runoff?
They are really nasty. I think it depends on the concentrations. Daphnia has been shown to accumulate metals as well. So it's depending on the concentration. If it's a huge high dose, they probably die from it. But if it's in trace levels, which is typical of these runoffs, it's possible that it will perform as it should.
Thank you. Right, I'm out of questions.
Does anybody else have any questions? I mean, I'm just absolutely blown away, and I'm feeling really, really positive now. I wasn't so much earlier today, but I'm feeling really positive now and hopeful that this can be driven forward and implemented. Anyone else, any questions?
No, well, what I'll do is I'll finish off on our standard last question, Luisa, is do you have a recommendation for an inspirational book that you could suggest?
Yes, so I included in the chat before. This is a book from a Nobel Prize, Rita Levi-Montalcini. The original book is in Italian, but it has been translated, and it is about imperfection. So as I mentioned to you before, I really admire her. She was a Nobel Prize, so a very smart woman. She contributed so much to science and medicine, but she was still very much aware of human imperfection and how to deal with it. And I think that book is inspiring in that respect.
Well, I'll search it out and give it a listen. Well, thank you very much. And just a reminder, our next Voices of the River is going to be with Dr. Lucian, which I'm quite excited about. He's an incredible human being. So yes, all the details of that will be shared on our social media, including links and on Eventbrite. So please seek that out and sign up. Pop it in a diary so you don't forget. And that will actually be, I think, our penultimate Voices of the River. So yes, remember the rest of the library is all on our YouTube channel at Even Load if you want to listen back.
Thank you so much.
Thank you
very much.
again, Lucy. It's been absolutely fabulous having you on.
Thank you.
Thank you.
Take care,
Bye-bye.
everyone.
Bye.
Bye.